You don't know. So who saw that rocket landing this week? That was
I saw it on television. Yeah.
I saw it.
Third time's the charm.
What's going on in space for astronomy the week before the meeting, so we can have something to cheer us on as we get started. So I'm going to let Sandra introduce our speaker, and we'll have our program. Then we'll take a short break, and then we'll have a brief information meeting for a few announcements and new members and stuff like that. But it's 7 o'clock, the room is full, so we might as well get started because there's no room for anybody else to come in anyway. So I'll turn it over to Sandy to introduce our speaker. Thanks, Sandy.
Thanks, Rich. It's great to see a full room like this. This is awesome. We're nothing if not cozy. I apologize for the guys standing in the back, but there's probably a little space up here if you want to pull up a chair. It's really my pleasure to introduce tonight's speaker. Phil Rossimondo is a charter member order of the Planetary Society. He's a space enthusiast, as most of us are, and has been so since the beginning of his career. He graduated from the University of Chicago with a master's degree in information science and completed PhD coursework in education at Walden University. He has spent over 35 years in technology-based positions, primarily within the defense industry. Phil has also taught at the university level at Penn State and DeVry University. He recently retired and is now looking to write the next chapter in his life story. So please welcome Phil.
Well, I jumped the gun here. Okay, first, as I said, my name is Phil Rossimondo, and I am the outreach coordinator of the Planetary Society. I can't seem to get that to work. One more time, if it don't work, we won't do it. How do I move the mouse? I don't? Then don't worry about it. My name is Phil Rossimondo. I'm the outreach coordinator for the Planetary Society. For those of you who don't know us, planetary.org is our website for the nation, and our Facebook site is www.facebook.com/tpsphi, and all this stuff is covered too on my Facebook site. I wish to welcome you to our presentation on interstellar space travel. Okay. Your children may be the first to experience, or grandchildren, to engage in interstellar space travel, but only if you have the vision to make it so. Okay? And also beware of predicting the future using the technologies of today. So, why interstellar space travel? Well, in the past, the human species was driven to explore the unknown because of a need to go where no one had gone before, acquire more living space, secure scarce resources, and obtain a better life for itself. Well, we still have these drivers today. However, the context has changed significantly. Where before there was plenty of space, now our resources and land is usable land is being reduced significantly. For example, 70,000 years ago, the population of the Earth was 10,000. By 1928, it had risen to 2 billion. By 2012, it went to 7 billion. By 2040, it should go between 9 and 10 billion. And by 2100, our population, assuming we don't kill ourselves in a war or something, should go to 16 billion. Okay? Many mouths to feed. We're actually using 1.6 Earth resources. Okay, so we're using 6/10 of a world we don't really own in our renewable resources. For example, one thing that, whoops, let me see, wrong button. Now, before I go into the water issue, I think I said that. Here's something interesting. The amount of water on the Earth is much more limited than people realize. We have these big oceans, and you think that's plenty. Well, actually, it's not. Although water covers 70% of the Earth, it only makes up 10% of the mass of the Earth. In fact, if you took all the water and put it together, it would only give you a drop about half the size of the United States. Of the water that's of the Earth, 98% is salt water. 2% is fresh water, and of that 2%, less than 1% of fresh water is usable by us, by humans. Okay? And most of that water is in rivers and streams, and we're polluting them. Okay, so a big issue. We may find that people are fighting over water. In addition to water, we're also having issues with fossil fuels. Okay, and in short, we live on a small, tiny speck of a spaceship Earth. And if we don't do things or something about it, we're liable to become extinct. In fact, in addition to resources and politics and all the other issues we keep running across, one of the things we have to be concerned with too is boloids, asteroids, and comets from outer space. In 2013, make sure I get the right button this time. Okay, in 2013, the Chelyabinsk meteor, which was 66 feet in diameter, it exploded in midair over Russia. Had it hit, it would have exploded with a force of 500 kilotons. For those of you who don't understand what a kiloton is, the dinosaur-killing boloid, which was 6.2 miles in diameter, exploded off the Yucatan Peninsula with a force of 100 million megatons. Okay, a little bit more than that. And to go a little further, the atomic bomb that was dropped on Hiroshima on August 6th had a power level of 15 kilotons. And the other atomic bomb, the one we dropped on Nagasaki, had a yield of 20 kilotons. Peanuts to what these asteroids and comets could do if they hit us. In 2015, the Halloween near-Earth object came within 1.3 times the distance to the moon to hitting us. And in 2016, this year, we just got missed. Well, it was supposed to go within 11,000 miles. That was the time, my last presentation, I was told. It turned out it passed us. It went to a distance of 2,500,000 miles, or about 10.64 times the distance to the moon. But the interesting point is, had it been 6 hours earlier, it would have hit the Earth. Okay, because the Earth was where it went through. Now, the thing about this asteroid, by the way, the Jesus Christ here, this is from South America. This is how big 125 feet is. Okay, that's the diameter of that asteroid that almost hit us. And the Jesus is 125 feet tall. And if you could see the teeny-weeny people there, that's what a difference would be. Very interesting, I think. The next one, I think, is even more interesting. Oh, and by the way, these are all the known asteroids that orbit near-Earth asteroids and comets. Basically, there are 10,000 near-Earth asteroids ranging in size from 1 meter to 32 kilometers, with 1,000 over a kilometer in diameter and able to cause vast climate change. Okay. In the past, for those of you who haven't, we had a few hits. For example, the Wilkes-Land Antarctic asteroid hit 250 million years ago and caused the Great Dying. Basically, it drove 97% of all life on Earth into extinction. Okay, and the crater is buried under the Antarctic ice, but we have new radar penetrating satellites which photograph the crater. This asteroid, the Wilkes-Land asteroid, was 30 miles in diameter. It created a crater 300 miles wide. The asteroid or comet that hit 65 million years ago, bringing about the extinction of the dinosaurs, was 6.2 miles in diameter. It created a crater 100 miles in diameter and 12 miles deep, and of course wiped out the dinosaurs. 28,000 years ago, an asteroid larger than the asteroid that exploded over Russia back in 1908, the Tunguska asteroid, exploded over North America, and it may well have led to the extinction of the Clovis people and the woolly mammoths. So, men like Stephen Hawking believes, based on this and the resource issues and the war issues and all that other stuff, that we're lucky if we survive 1,000 years. Okay? He believes that in 1,000 years, man will be extinct. Okay, what do we do about it? Well, of course, there's a lot of things we can do on Earth, and we got to get our government to help us there. But beyond that, and beyond our solar system, exoplanets may prove to be our best hope for the survival of humanity. Okay? Exoplanets, let me sure push the right button again. Exoplanets are planets outside of our solar system, and we need to find stars with human habitable planets, new Earths. Okay, such planets may be insurance policies against our own extinction, and two techniques have been adopted mainly. This is the transit method and the Doppler method of detecting planets. Okay, we will talk about the transit method this evening, and when you down my way, I'm teaching a 5-week course on this. We'll talk about Doppler method too. But anyway, a transit is actually when a planet passes in front of its star. Like for instance, when Venus or Mercury pass in front of the star, which is our sun, you get a transit, a little black dot. And you have something called a depth of transit, okay, which is the drop in the Kepler satellite is now at 75 million miles from Earth, and its purpose was to find exoplanets. It's focused on one small area of the sky, specifically the area marked by the constellation Cygnus the Swan. Okay, Kepler is a photometer and able to detect a 0.01% depth of transit of an Earth-like planet passing in front of a sun-like star. Okay, and basically by comparison, that is equivalent to being able to see a fruit fly flying in front of the headlight of a car over a mile away. Okay, Kepler so far has detected or identified 5,000 potential planet candidates, and we have identified through various methods using Kepler's 1,000 actual planets. Okay, Kepler's mission was curtailed back in 2013 because of the death of 2 of its 4 reaction wheels. And actually I heard tonight that it's now been put itself in emergency mode as of today. Okay, but it's continuing, or was continuing up to today, using its solar sails to keep the satellite pointing in the right direction. Okay, and so basically we have the depth of transit. Here, sun is brighter, low at depth. Here's another star, which we'll talk about in a second. Okay, one other comment is the Planetary Society is currently working with professors from Yale and UC Berkeley to find exoplanets. And they are looking for planets that orbit or in the area of Alpha Centauri. And if you guys remember the movie Avatar, okay, there might be a planet or a moon around orbiting the planet. So who knows what we'll find. Anyway, see if we get this right. Okay. Of the stars that have been discovered so far by Kepler, one in particular is of special interest to us in a particular system called the Kepler 186 system. The Kepler 186 is a star, and it is, as I said, found in constellation Cygnus. And over here, I assume everybody knows how to find Cygnus. Okay, and where to look if you want to look for it, it's up over here. Okay. The star is a class M red dwarf star, okay, and it is much smaller than the sun, and the planets that are orbiting it are also small. Okay, of the 5 known planets, the 5th planet, Kepler 186f, is of particular interest because it orbits in the Goldilocks zone. Okay, the Goldilocks zone is that area around the star where the temperature is such that water can remain in a liquid form. And we currently believe that liquid water is essential for life. So it could be that there's life on that planet. Okay, in fact, Kepler 186f, they've run it through some models, and according to the model, given the statistics they've identified, it has a temperature of 72 degrees Fahrenheit. So here we've got a stony planet, about 1% larger than the Earth, 500 light years. 500 light years. Thank you very much for asking that question, because I wanted to make sure you understood, and we're talking about light years in a little bit, that we're talking about time as well as distance. Okay, so here is what I was saying about Kepler 186f. Okay, it was discovered in April 2014, and as I said, about 10% larger than the Earth, and it's the closest planet that has been found in size to Earth that is in the habitable zone. It takes 130 days to orbit its star. It gets about 1/3 the energy that we get and orbits 3 times closer. Okay, and there may well be water on that planet. Now, this was the state of the system back in when I first started giving these presentations. Since then, last year, I was very excited to find that they had discovered another planet, Kepler 452b, which is an Earth-sized exoplanet orbiting a sun-like star this time, a star that's practically identical to ours. It's older and a little hotter than ours. Kepler 452b was found last year, 2015. It's 60% bigger than Earth, and it orbits its sun-like star once every 385 days. And for people who like to know how far it is, it's 1,400 light years. A little far, huh? Okay, the point that I wanted to bring out too is, remember, when we're looking at stars, we're looking at what they were in the past. And of course, what is a light year? Okay, that, by the way, in the past, that means some of the stars might not even exist anymore. We haven't found out that. Okay, first of all, you have to understand light years in order to understand this presentation, as well as astronomical units and several other types of measures. But the distance light travels 1 year in a vacuum is light travels at 186,000 miles per second, which is 671 million miles per hour. So a light year is about 6 trillion miles. Okay, light travels so fast that it can make 50 back and forth trips between New York and London in 1 second. Or in 1 second, travel 7 times around the Earth. Okay, it takes 1.28 seconds to go to the moon, and 8 minutes to come to us from the sun. Of course, the sun might be gone right now, but we won't find out for 8 minutes. Okay, the nearest star to us is 4.2 light years away, or 25 trillion miles. Okay, and that's basically to say, if we measure the distance from the sun, the Earth would be about 1 mile away from the sun, and Proxima Centauri would be in Los Angeles. So a little difference in distance. If we consider some other fun facts that I consider,